Okay, class, what you should have out on your desk at this time is your notebook, your pencil, and a scientific calculator. Something that looks like this. A scientific calculator. Now it can be one of your own, or it can be one of mine that you are borrowing, as long as it has sine, cosine, and tangent keys on there. As long as it has sine, cosine, and tangent keys on there. Okay. What you're going to be working on today is how to find missing angles, and later on next week we'll find out how to find missing sides. Okay. This is 7.3b continued, or 7.3b, trigonometry continued. Today's date is the 1st. Trigonometry continued. Part 1, review. Okay. SOHCAHTOA. Remembering what SOHCAHTOA stands for, so that when you're working these out, you have no problem getting through them. Okay, so remembering S stands for sine, not sin, and its opposite over hypotenuse. C stands for cosine, which you can call cos if you want. Cosine cos is A over H, which is adjacent over hypotenuse, and tangent or tan is opposite over adjacent. Okay, part 2, find the missing side. Find the missing side. And I'm going to put in parentheses here, round to the nearest tenth. Round to the nearest tenth place. Okay, number 1. Alright, so you have your right triangle, and I am going to label this as 15 and this as X. And I will label this as A, B, C. Okay. Find the missing side. Okay, a few things I want you to recognize. First, we do not have enough information to use Pythagorean's theorem. Yes, Pythagorean's theorem is a squared plus b squared equals c squared, where c is 15, but I cannot do a squared plus b squared because this is x and I don't know this side, so I do not have enough information. Second, I am not going to use the special triangles that we learned On block day, we cannot use these because these are only used when it's a 45-45 90 or a 30-60 90, which this is not. We don't know what angle A or B are. It could be any combination that would add up to 180 for these three angles. Does that make sense? So this could be 50 and this could be 40. We don't know the angle measure, so we cannot use the special triangle business that we did here on block day. Okay, so this is new stuff, and we're going to be using our calculators. All right, so here is what you do. When you're doing these problems, first thing you're going to do is look at which angle was given. Besides the 90, we're not going to use the 90. So we look at the angle that is given, and in this case it is it's neither because I didn't give it to you. I apologize. This here should be a 71 degrees. That will be given. Again, I just forgot to write it in, but that should be a 71 degrees. Okay, the next thing you're going to look to see, okay, which angle is given. And it's angle A, so I'm putting myself sitting at angle A. Technically, if you wanted to, you could use angle B if you did add and subtract from 180, but we're not going to waste our time because 71 is all we need. Okay, after you've done that, start to label your sides. Okay, opposite the C is the hypotenuse. In reference to the 71, X is the opposite or the adjacent. In reference to angle A, or angle 71, in reference to this angle, is X opposite or adjacent? And I'm hoping everyone's saying adjacent. Now, I'm not going to label this side for two reasons. Well, one big reason, we don't need it. We're not looking for this side. They're not asking for that side. They're just asking for X, which is adjacent. Why did I label this side? Because they gave it to me. 15 right there, it's given. So I'm labeling. All right, so you use SOHCAHTOA and you ask yourself which one deals with adjacent and hypotenuse. AH, that's this one right here. Do you see that? So cosine is what we're going to use. Okay, so this is new. I need everybody paying attention. Cosine is what I'm using. Why cosine and not sine or tangent? Because cosine is the only one that deals with adjacent over hypotenuse. Do you see that? And I'm looking for adjacent, and I know the hypotenuse. So I'm going to write this as X over 15. Okay, I'm going to pause there and give everyone a second to digest and make sure you understand. Without talking. Okay, one more time. I put my little dot at 71 because that's the angle that was given. I then labeled the given side as my hypotenuse and my unknown side is the adjacent because that's X. And I don't label this side because we don't need it, don't care about it. Okay, now how would I solve this? If I'm trying to find X, I am going to multiply both sides by 15. Okay, or another way you can think of it, and this might be easier for some, is to think of it as cross multiplication. That's another way to think of it. So I'm going to erase these 15s. It's going to work out the same way, but I'm going to show it that way just because I know this is a place where a lot of kids mess up. I'm going to write a 1 under here, and I'm going to cross multiply. 15 times cosine. And I did mess up in one piece that I do need to fix, otherwise we will not be able to do this problem. I wrote cosine equals x over 15. That is not correct. It is cosine, but it's cosine of an angle, and it will always be cosine of an angle. So I'm going to erase and squeeze it in there. Cosine of angle A, or in this case, since we know it, cosine of 71. So if you will please fix that as well. Cosine of angle 71 equals adjacent over hypotenuse. Cosine of 71 equals adjacent over hypotenuse. All right, now we're going to cross multiply. I cannot multiply the 71 degrees with the 15, but I can write it like this. 15 times cosine of 71 degrees equals x. And this is where we will use our calculators. But let me repeat what I've done. 15 times cosine 71 equals x. You will not ever multiply the angle with the number. You will never multiply 71 and 15. 15 comes out to the front, and cosine 71 comes after. 15 is the coefficient, cosine 71 is the function. Okay, so we're going to plug all of this in our calculator. So turn your calculators on, hit clear, and this one's really hard to see, but I'm hoping it shows up on your, you can see it better on your own. Okay. All right, so how do I type in 15 times cosine 71? With these nice calculators, when you can read them, you actually type them in just as you see it. 15, that is really hard to see, times cosine 71. Cosine 71. Alright, I'm still here. I'm going to get the light back on. I apologize. Okay, I just had to adjust to see the screen better. Okay, so I am going to repeat what I did since we couldn't see it the first time. Okay, so that is 15, because we're typing in, where is it at? 15 cosine 71. So 15 times cosine, my cosine key is right here, look for yours, and it shows up as COS, and then 71 degrees. And I'm going to close my parentheses. You don't have to, but I'm going to. And then your equal sign, and 4.883522317. All right, and it's around to the nearest tenth. So nearest tenth place would be 4.8 or 4.9. That would be 4.8. So x equals 4.9. I'm not sure if that's what I said, but that's what it is. X is 4.9. All right, if that did not make too much sense, we're going to try another one, and hopefully it'll be a little clearer. Okay, number 2. Right triangle. Here's my angle. Here is x. This is 40 degrees. This is 17 degrees. ABC. And again, this is not a special triangle, 45, 45, 90. It's not, because 40 and 90, it doesn't work. It's not a 30, 60, 90, and we cannot use Pythagorean's theorem to find this missing side because I do not know the length of BC. So I cannot plug in a squared plus b squared equals c squared if I do not know this side length. I know this angle is 40 degrees, but I do not know side length BC. Okay, so what do? You put your marking at the angle that's given. And since 40 is the angle that's given, I'm going to put my red pin mark there. Now technically, you do know angle A as well as 50. And if you wanted to use that one instead, you can. Your work will look different from mine initially, but in the end, we'd end up with the same answer. So I label everything in reference to the 40. What is x in reference to the 40? Opposite or adjacent? Correct, it is opposite. What is x in reference to angle 40? It is opposite. BC is adjacent, but I'm not going to label it because I don't need it. I'm just going to waste my time. It's not needed. But they did give me 17. They'll always give me one side. You will label that side as well. And that side is the hypotenuse. And it doesn't matter if you're at angle A or angle B, 17 will always be the hypotenuse. Okay. So we're going to set this up. We are going to have, oh, well, let's figure out. I have opposite and hypotenuse. So let's come up to our SOHCAHTOA. Which one here is opposite and which one here is opposite over hypotenuse? I'm hoping everyone's recognizing its sine. So we're going to do sine of an angle. And what angle are we using? The 40. Sine of an angle, sine of 40, equals opposite over hypotenuse, opposite over hypotenuse. So when we do that, we have opposite, which is x, over hypotenuse, which is 17. I'm going to put a 1 under here. And we're going to do what we said earlier and cross multiply. Okay, so there you end up with not 17 times 40, but 17 times sine of 40. Okay, it's not 17 times 40, it's 17 times sine of 40 equals 1 times x, which is just x. Okay, how do we plug this in our calculator? Just like this, 17 times sine of 40. That's what's nice about these scientific calculators. You can plug it in exactly as you see it. I'm just going to clear that out. You can leave it and just go on the next line. Okay, where are we at? 17 is the first thing I type in, 17. And then times. My sine key for my calculator is right here, right above 7x to the negative 1, and then the sine. So I type that key, then the saying, hey, sine of what angle, and what angle were we dealing with? The 40. Close my parentheses, which is above the 9. If you don't close it, it's fine, it's still going to work. And then your equal sign, 10.92738936. And you want to make sure that you're using a calculator, when you're doing homework, that you're using a calculator that you'll use in the test. For example, if you're using your phones on homework, that's fine, but come test day, you can't use your phone, so you cannot ask me on test day, how do I plug things into this calculator, because I'm not going to answer that. So use a calculator that you're used to using. And if it's new to you, then get a calculator and use it throughout the unit, throughout the homework, and be ready for the test. All right, nearest tenths place, 10.92. So does that 9 change or does it stay 9? Since the 2 is smaller than 5, it's going to stay 9, so 10.9 is the answer. X equals 10.9. Okay, number 3. Number 3, I'm going to put stars by because this one's tricky and it gets kids every year on the test. So let me show you why it's a little different. Right angle. This angle in here is 57 degrees. Again, angle A is 57 degrees. Length CA is X, and length BC is 14. All right, put your red pin mark in the angle that you know, and if they happen to give you both of them, pick one. It does not matter. Again, if they give you angle A and angle B, mark one and stick with that one. It does not matter. In the end, if you picked angle A and your friend picked angle B, your work will look different initially, but in the end, you'll end up with the same answer. Okay, if I'm sitting at angle A, what information is given? 14 is given, and what is 14 in reference to angle A? Opposite, adjacent, or hypotenuse? Correct, it is opposite. X is what I'm looking for, and what is X in reference to angle A? Opposite, adjacent, or hypotenuse? I'm sorry, this one I'm looking at X. What is X in reference to the angle 57 or the angle A? Opposite, adjacent, or hypotenuse? Correct, it is adjacent. Now, there'll always be one side I don't label. Notice I labeled adjacent hypotenuse. I labeled opposite hypotenuse. And here I labeled adjacent and opposite. I'm not labeling the hypotenuse on this one, and why is that? They're not asking me for it. They didn't give me it. It's not necessary, it's not needed, I can ignore it and be perfectly fine. I have enough information without it to find my X. Okay, so there'll always be like one lonely side over here that they don't label, you don't label. One lonely side here that they don't label and you don't label. And this one happens to be the hypotenuse. Okay, so let's come back to our SOHCAHTOA. Which one deals with opposite and adjacent? Good job. It is tangent. Tangent is opposite over adjacent. So now we're using tangent of the angle, always of an angle. Tangent of 57 degrees. Again, it's always tangent of an angle. Equals opposite over adjacent. Opposite over adjacent. 14 over X. Tangent, because we're dealing with opposite adjacent, they didn't give us hypotenuse, they didn't label it, so we didn't label it. Tangent of 57 is 14 over X. I'm going to put a 1 under here and cross multiply. X times tan of 57, I write like this. X times tan of 57 equals 1 times 14 is 14. All right, X times tan of 57 is X tan 57. Just like 17 times sine of 40 is 17 sine 40. Same concept. 17 is the coefficient, X is the coefficient. All right, now here it was easy. because we just plugged in our calculator. 17 times sine of 40 equals x. Here, I'm looking for x, so I can't plug this in my calculator. I can't plug in x times tan of 57 because I don't know what x is. But there is an extra step here. There's an extra step because here and here, x was already isolated. Once you cross multiplied, x times 1 is 1x, 1 times x is 1x. X was isolated. All you had to do was plug in. Here, x is not isolated. X is not by itself. So what do we divide both sides by? Tan of 57. Now, for whatever reason that freaks people out, but tan of 57 is just a number hiding in your calculator. It's hiding and waiting for you to plug it in and figure out what it is. All right, so we do plug this one in just a smidge bit different. So I'm going to get my calculator back out. Turn it on, clear. Okay, so this right here is what I'm plugging in. So instead of multiplying like I did here, this was 17 times, I'm going to use my division key, and that is the only difference. So I type in the 14, but I use my division key instead of my multiplication key. So 14 divided by tan of 57. The tan key is here, sine, cosine, tangent. Tan of 57, close my parentheses. Again, if you don't close it, it's not detrimental. You will be okay. 14 divide tan 57. Hit equals or enter. 9.091706305. To the nearest tenths would be 9.0 or 9.1. Since the 9 is bigger than 5, it makes this become a 1. So 9.1 is the answer. Now I know this may seem confusing, but I promise you with more practice, we will get better. Okay. I am going to move on to part 3 of the notes. Last part, part 3 is find the missing angle. Find the missing angle. I will put in parentheses here, round to the nearest whole number. All the last set was round to the nearest tenth, but now we're rounding to the nearest whole number. All right, so what were we doing on the other page? This other page we were looking for the missing side, and now we're looking for the missing angle. It does change the way we do things, so you want to make sure you recognize and understand how to address each one. So when you're doing homework or test or a quiz, look and ask yourself, what am I looking for here? Am I looking for an angle, or am I looking for a side? Because you will treat them differently. They will look the same initially, but if you look to the details, you will see the difference. All right, number 1. All right. Triangle ABC, where the hypotenuse is 15 and BC is 7. And I'm going to put that in there, and I'll explain what that is. Okay. That symbol there is not a 0. Let me write down what that is. We pronounce that theta. It's part of the Greek alphabet and it's commonly used for angles. We'll also use alpha and beta a lot in advanced math, but theta is one commonly used in this class and even in advanced math and math 3. So you want to know not only how to recognize it, but how to say it. Theta, T-H, theta. That's an E. All right, so let's figure out how to do this. First off, we're still going to be using our SOHCAHTOA. And just like we've been doing, you're going to label. Okay, find the missing angle. The missing angle in this case is theta. Wherever they put the theta is the angle you're looking for. Or they will say find angle B or find angle A. If they just say find the missing angle, you're looking to see which angle they've labeled. In this case, it's theta, which is angle A. Got it? Or they say find theta. They'll label it or ask for it different ways. Okay, so in reference to theta, what is side BC? This is theta. Is that opposite, adjacent, or hypotenuse? Good job, that is opposite. What is 15? Opposite, adjacent, or hypotenuse? Good job, that is hypotenuse all day long. That's always the hypotenuse. It doesn't matter if you're at angle theta or angle B. 15 is the hypotenuse. All right, so you're going to do this just like we did the last one, at least initially. So you're going to set up, I guess I should look at it first. I didn't label this side. There'll always be a side I don't label, just like the other page, because they didn't label it for us, so we don't label it. Opposite hypotenuse. Which one here deals with opposite hypotenuse? Correct, it's sine. So I write down sine, not sin, of an angle. Now I could call it angle A, but I'm going to call it theta since that's what it's called on the paper. Sine of theta equals. Now how is that? That's where I said earlier, if you pay attention to details, you will see the difference. Here, they gave me an angle. They gave me an angle. And the unknown is a side length. They gave me an angle and the unknown is a side length. Here, they gave me 2 side lengths and the unknown is the angle. Either way, you will always do sine, cosine, and tangent of an angle. Whether that angle is a number, like 71, or if that angle is an unknown, like theta. Sine of theta equals opposite over hypotenuse. Opposite over hypotenuse. 7 over 15. And you will not cross multiply. So if you are Speeding Gonzalez and you're working ahead, stop yourself. You will not cross multiply. Now this is where it gets tricky. So I need you guys listening. All right, we have a special key in our calculator that allows us to solve this. Right now, we don't have the tools in our brain to say, sine of what angle is 7/15? We can ask it, we can say it, sine of what angle is 7/15? But we don't have the tools in our brain or to cross multiply and solve to do this without a calculator. You need a chart, which people have used in the past, or a calculator. Okay, so here is what the key looks like. If you look in your calculator, you will see a key that looks like that. And it's most likely right above your sine key. So if you look right above your sine key, you will see sine to the -1. Right above your cosine key, see cosine to the -1. And right above your tangent key, you're going to see tan to the -1. Now this is awesome because we're going to be using a whole lot of keys here that you've never even known how to use before. You don't even know why they were there in your calculator, and we will be using them all unit long. All right, so sine of, or inverse sine of 7/15 is how we're going to plug it in our calculators. All right, so a few things. First off, I said, you always use an angle here. You always use an angle. And then I have a kid say, Mrs. Torres, this isn't an angle. This is a side. This is a fraction of side lengths. But this is no longer sine. This is inverse sine, is how you say this. The inverse of sine. The inverse of sine. All right, the inverse of sine. All right, so how do you plug it in your calculator? Very easily. Turn it on, clear. Hit your second key, your shift key, whatever key it is on your calculator. For mine, it's second. So I'm going to hit second. And then my sine key. And you see where it has a little -1 there, so you know, hey, we're finding the inverse. Inverse sine of the side lengths. The fraction is what? 7/15. So 7 divide 15, close parentheses. Now, before I hit equals, this is telling the calculator, I know that my opposite over adjacent is 7/15. Can you tell me what the angle is? Again, you're telling the calculator, I know my opposite side is 7. I know my hypotenuse side is 15. Can you tell me what the angle is? That's what you're telling the calculator right here. And when you hit enter, ba-boom, it comes out and says, hey, this is the angle measure. So 27.81813928, which is amazing that this calculator can figure out what the angle is going backwards. You gave the calculator the answer. You said, hey, I know the answer. I know sine is 7/15, but I don't know the angle. So you plugged it in backwards and it came up with the angle for you. Now I said earlier, angles will always round to the nearest whole number. So is this 27 or 28 degrees? And it is 28 degrees. Now if you're like, whoa, that is just crazy, we will do a few more. And hopefully it'll make more sense as we go. Number 2. All right, triangle ABC, where CA is 5 and the hypotenuse BA is 12, and I'm going to put theta here. All right, so just like before, you are going to mark the unknown, which is theta, and then you're going to label your sides accordingly. Okay, they didn't give me this side, so I do not care about it, and I'm not going to label it. They did give me CA. In reference to angle theta, what is 5? It's opposite or it's adjacent. Good job. I'm hoping you said adjacent. In reference to theta, what is 12? Good job. I'm hoping you said hypotenuse. And I said in reference to A on purpose, but it doesn't matter if you're sitting at A or B. 12 will always be your hypotenuse all day long, every day. Okay, so let's continue. Let's go to our SOHCAHTOA. Which one deals with adjacent over hypotenuse? Cosine. Good job. Cosine of an angle, and since they did not give me an angle and the angle is what I'm looking for, I put in theta. Cosine of theta equals adjacent over hypotenuse. Adjacent over hypotenuse. Do not cross multiply. If theta is unknown, if your angle is unknown and your angle is what you're looking for, you're always going to use your inverse key. This is called an inverse key. All right? If your angle is unknown, if the angle is what you are looking for, you're always going to use your inverse key. So here, you're thinking, I don't know the angle. Oh, I'm probably going to use the inverse key. And this is how we write it on paper. And I write it like this because this is exactly how it looks when I plug it in my calculator. Inverse key, inverse of cosine. So let's get our calculators ready. Clear, second cosine, and there it is with the -1. Tell me that's the inverse of cosine of 5/12. 5 divided by 12. Again, you're telling the calculator the answer. You're saying, calculator, I know the answer. I know that cosine of this unknown angle is 5/12. Can you give me the angle? And it gives it to you. Again, it's working backwards. You know the answer, but you don't know the angle. So you plug it into the calculator using your inverse key, going backwards key, and hit enter, and there's the beautiful angle, 65.37568165. All right, so we round to the nearest whole number. Is that 65 or 66? Good job, it is 65. Theta equals 65 degrees. And again, I'm rounding to the nearest whole number because it's stated here, and with angles, we will typically always round to the nearest whole number, at least in this class or this unit. Number 3. All right. Draw your right triangle, ABC. I'm labeling CA as 7 and BC as 12. And I put theta in this corner over here. Theta will not ever be in your right angle. All right, same as before, same as we've been doing, label your sides in reference to your theta. Theta is what we're looking for, so I'm going to put a little red dot there. If I'm sitting at theta, what is the 7? Opposite, adjacent, or hypotenuse? Good job, it is opposite. What is 12? Opposite, adjacent, or hypotenuse? Now you may be thinking, that's next to and that's next to, so which one's which? Well, we know that one's the hypotenuse, so that means this one is the adjacent. And I don't need to label the hypotenuse because it wasn't given to me. Again, you're always going to leave one side blank. The side they leave blank, you will leave blank. Don't label, don't label, don't label. And come back up to your SOHCAHTOA. Which one deals with the opposite and adjacent? Good job. It is tangent. Tangent of an angle. Tangent of an angle. And since we don't know the angle, we put tangent of theta, because that's the unknown angle. Tangent of theta equals opposite over adjacent. Opposite over adjacent. And as I've stated before, if theta is what you are looking for, if that is your unknown angle, then you're going to be using the inverse key. Your inverse key being the -1 key. And since we don't know the angle, we do not cross multiply, we use the inverse key. Inverse tan of 7/12. And that's the way you plug it in your calculator. All right, so let's get our calculator ready. Clear. Don't forget, you always hit second or shift, second, tangent, and there's a little -1 telling me I'm using my inverse key. 7 divide 12, close parentheses, And again, you're telling the calculator, hey, I don't know the answer. I don't know the angle, but I know the answer. I know the answer is 7/12 for tangent of this unknown angle. Can you tell me what the angle should be? And when you hit enter, ta-da, it gives it to you, 30.25643716. So then you say, what is this, 30 or 31? And I'm hoping you can say, oh yes, it's 31 degrees. Okay, so what I'd like you to do right now is first, I'm going to tell you right now, homework tonight, you will not have any of these tonight. Why did I do them? Because these will come up on other worksheets and on the test, but they're unfortunately not in tonight's worksheet. They should have been, and they were not. So these are the ones on tonight's homework and some reviews. So if you will please take that out if you do not have it out already. And I'm going to go over just a few of them really, really fast. So take it out. And I'm going to tell you right now, these first 4 are reviews. These first 4 are review. This is just using your basic SOHCAHTOA and figuring it out. I will do number 1 with you. Find cosine of theta. SOHCAHTOA. Cosine's adjacent over hypotenuse. So cosine of theta is adjacent over hypotenuse. So we label in reference to theta, which one's adjacent? That one is. This is your adjacent, and this is your hypotenuse. This one's opposite, but we didn't really need it in this case. So adjacent, hypotenuse, cosine of theta equals adjacent over hypotenuse. Adjacent over hypotenuse, and just reduce. What goes into 20 and 25? 5, so it becomes 4/5. Make sense? That's it. Again, these first 4 are no inverse key, no calculator keys, you're just basic review. Tan of theta, tangent is opposite over adjacent. So let's label those really quick. If this is theta, this is opposite, this is hypotenuse, and this is adjacent, and it's nice if you have it labeled. Tangent is opposite over adjacent, 9/12, and reduce. Go ahead and reduce that now. Three goes in, 9 divided by 3 is 3, and 12 divided by 3 is 4, so tangent of theta is 3/4. Review. These last 4 and the ones in the back are the new ones, so I'm going to go over that now. I'll do number 8 with you. This is part 3 from the notes. Find the missing angle. Find the measure of each angle indicated. Okay, so then again, this is the one where you're looking for angle. You're going to use the inverse key. You want to start making notes to yourself. If you're looking for an unknown angle, you're going to use the inverse key. So let's quickly mark, this is the unknown angle because they put it as theta. In reference to theta, this is opposite, and this is adjacent. They didn't give us the hypotenuse, so I'm not going to label the hypotenuse. And I take a look up here, so I'll just rewrite it. SOHCAHTOA. If I'm using tangent, I'd be dealing with opposite and adjacent. Do you see that? So tangent is the function I'm using. Why? Because tangent is the only one that has opposite and adjacent and no hypotenuse. Okay, of the unknown angle, we don't know what the angle is because that's what we're looking for, equals opposite over adjacent. And as I keep stating before, if your angle is what you don't know, you're going to use your inverse key. So, inverse tan of 15 over 5.2. Inverse tan second tan 15 divided by 5.2. 70.88, blah, 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 nearest tenth. Now, I know I said we want to round to the nearest whole, so I'm going to change this since I did state earlier we usually do angles to the nearest whole number. So I am going to change that if you don't mind. So what would this be, 70 or 71? That would be 71 degrees. All right, so don't forget to change that. We're rounding to the nearest whole number. And the rest of the worksheet is like this here, the inverse keys.